everyone. I am Dr.B.Krishnaveni, working as an assistant professor in the Department of Mathematics, Aditya University. Today we are going to discuss about the topic called diagonalization. So, what the condition has to follow in order to diagonalize the given matrix and how to diagonalize the given matrix. That's the topic we are going to discuss. So, what the learning outcome of this lecture is, at the end of this lecture, student will be able to diagonalize the given matrix into a diagonal matrix. So, first the student or we might know what is meant by diagonalization, in what kind of matrices it will be applicable, and finally we will come to know how to diagonalize the given matrix. So, now let us start the topic, the diagonalization of a matrix. So, in order to come to this, first let us know what is meant by similar matrix. When we call the matrix is similar, if we consider any matrix A, we call that matrix is similar to another matrix B if there exists a non-singular matrix P such that B is equal to P inverse AP. This transformation from A to B, we call it as similarity transformation. So, when we call a matrix A symmetric to B, if there exists a non-singular matrix P satisfying this condition, B is equal to P inverse AP, and we call this transformation is similarity transformation. So, now come to know what is meant by diagonalization. Let us consider A be a square matrix. If there exists a non-singular matrix P and a diagonal matrix D such that P inverse AP is equal to D, then A is said to be diagonalizable, and here D is said to be diagonal form or canonical diagonal of a matrix A. This we call it as diagonalization. So, I repeat, if you consider any square matrix A, if you are getting any non-singular matrix P and a diagonal matrix D such that P inverse AP is equal to D. It satisfies this, then we say that A is diagonalizable, and we call D is diagonal form or canonical form of the given matrix A. So, diagonalization, what meant by diagonalization is, diagonalization of a matrix is the process of transforming a square matrix into diagonal matrix D through similarity transformation. Here we are going to discuss about the diagonalization of a matrix through similarity transformation, that is given by P inverse AP is equal to D. Here we need to note some of the points. What that points are? Diagonalization is only defined for square matrices. So, that means for only square matrices we are able to diagonalize. A matrix of order n is diagonalizable if and only if it has n linearly independent eigenvectors. If A does not have n linearly independent eigenvectors, then it is not diagonalizable. So, in order to check whether A is a diagonalizable, we can do this. What that is? It is a diagonalizable if and only if it has n linearly independent eigenvectors, if suppose the given matrix is of order n. If it does not have n linearly independent eigenvectors, then we say that it is not diagonalizable. That is, if det P not equal to 0, then eigenvectors are linearly independent and A is diagonalizable. In other words, we can do or we can check this, that is geometric multiplicity and algebraic multiplicity of an eigenvalue. If geometric multiplicity of an eigenvalue is less than algebraic multiplicity of the eigenvalue, then the matrix is said to be defective. In such case, the matrix cannot be diagonalized. So, this is the condition we can easily check and can see whether the given matrix is diagonalizable or not. That means we need to check geometric multiplicity is equal to algebraic multiplicity for each eigenvalue of the given matrix, then only the matrix is diagonalizable. Otherwise, That is, if it is less than algebraic multiplicity, then the matrix is not diagonalizable. Now, in order to find a diagonal matrix, we need model matrix P. So, what meant by model matrix is, the model matrix which diagonalizes A is called model matrix of A. And to obtain this, we need to group the eigenvalues of A into a square matrix. That we call it as model matrix. And the resultant diagonal matrix D is known as spectral matrix. So, this is the model matrix by which we can make the matrix A into diagonal matrix, and can be obtained by grouping the eigenvectors of A into a square matrix. Now, what are its applications? That is, what the applications of a diagonalization of a matrix? First of all, we can use this in order to diagonalize a matrix. And the second is, it is used to find higher powers of a matrix such that A power n is equal to P d power n P transpose. P inverse it is. P d power n P inverse. So, now we will see the working rule in order to find out diagonalize of a square matrix. Now, we will see what is the working rule to diagonalize a square matrix A. Now, we will see what is the working rule to diagonalize a square matrix A. Let us consider A be the square matrix to be diagonalized. First, find the step 1, that is, find the eigenvalues of the given matrix A. Let us suppose those are given by lambda 1, lambda 2, so on lambda n. Next, go to step 2. Find the eigenvectors x1, x2, so on xn corresponding to these eigenvalues lambda 1, lambda 2, so on lambda n. Then find out the model matrix P is equal to the matrix x1 as column, x2, so on xn, which gives the another square matrix whose columns are the eigenvectors x1, x2, so on xn. Then find out the P inverse. Finally, find out the P inverse AP, which gives the required diagonal matrix of E. That is, P inverse AP is equal to D. So, this is the way to find out diagonal matrix using this transformation. So, let us discuss the question on this. The question given by, the diagonalize the matrix A is equal to 1 0 minus 1, 1 2 1, 2 2 3, hence find A power 5. So, now first find out, as per our working rule, we need to find out first eigenvalues, then the corresponding eigenvectors. For that, we need characteristic equation for the given matrix, and is given by det A minus lambda is equal to 0. That is, det of 1 minus lambda 0 minus 1, 1 2 minus lambda 1, 2 2 3 minus lambda is equal to 0. Now, how to find the characteristic equation of this matrix? By means of the property, the direct formula which we can calculate characteristic equation of this det of this step given by lambda cube minus trace of A into lambda square plus minus of A11 plus A22 plus A33 into lambda minus det A is equal to 0. First, let us find trace of A. Trace of A is sum of the diagonal elements, 1 plus 2 plus 3, that is equal to 6. Minor A11. How to find minor A11? Means, first consider A11 element, and what is the minor is? Need to consider this elements, that means the elements which do not contain 1, need to consider that and need to find out the determinant, that gives minor A11. Next, consider minor A22, which gives this element. Delete the row, column containing the element, and det of remaining elements, that is det of 1 minus 1 2 3, that is equal to 5. Finally, minor of A33, this is an element, and now by deleting the row and the column containing this element and consider the remaining elements 1 0 0 1, and det of that is equal to 2. Some of those minus we need to consider here, And finally need to find out the determinant of A. 3 by 3 matrix determinant, after calculating we got det of A is equal to 6. Now substitute all these values in this equation, then the characteristic equation is given by lambda cube minus 6 lambda square plus 11 lambda minus 6 is equal to 0. Now on solving this we will get roots, though the roots are that equation given by 1, 2, 3, which we call it as eigenvalues of A. So hence we got the eigenvalues for the given matrix A. Now need to find out the corresponding eigenvectors. So now let us find out eigenvector corresponding to the eigenvalue lambda is equal to 1. By means of A minus lambda is equal to 0, and by taking lambda is equal to 1, we got the equation A minus I of x is equal to 0. On doing that, we got this equation which is given by matrix 0, 0, minus 1, 1, 1, 1, 2, 2, 2, x, y, z is equal to 0, 0, 0. So now need to find out the solution of this homogeneous system, and for that we have applied this operation R3, R3 minus R2, then we got this equation given by 0, 0, minus 1, 1, 1, 1, 0, 0, 0, x, y, z is equal to 0, 0, 0. Now it is very clear that the rank of this matrix A is equal to 2, which is less than number of unknowns, that is equal to 3. So therefore it has infinite solution. First take the reduced system. From this we got equation x plus y plus z is equal to 0, and from this minus z is equal to 0, that is z is equal to 0. Now need to fix one variable as arbitrary constant. So here we fixed y is equal to k, therefore we got x is equal to minus k by taking z is equal to 0. So out of x, y, in this equation we got what z value is, and to find out x we fixed y is equal to k, which is a constant, arbitrary constant. Then we are able to find what is x is equal to, given by minus k. So therefore the vector corresponding to lambda is equal to 1 is given by x, y, z minus k, k 0, that is equal to k into minus 1, 1, 0. Hence we conclude that vector 1, minus 1, 1, 0 is the eigenvector corresponding to lambda is equal to 1. Next consider, or next find the eigenvector corresponding to the eigenvalue lambda is equal to 2. Again by means of equation A minus lambda x is equal to 0, on substituting lambda is equal to 2, we got the equation A minus 2i of x is equal to 0. On doing this, we got this, that is minus 1, 0, 1, 1, 0, 1, 2, 2, 1, x, y, z is equal to 0, 0, 0. So now need to find out again the solution of the system. For that, here we applied row operations, R2 as R2 plus R1 and R3 as R3 plus 2R1. Means here we fixed this and we make these two zeros using row operations. On performing this, we will get this. The first row is minus 1, 0, minus 1, 0, 0, 0, second row, and the third row is 0, 2, minus 1, x, y, z is equal to 0, 0, 0. Clearly again the rank is equal to 2, which is less than number of unknowns. Now let us consider the reduced system given by x minus z is equal to 0, 2y minus z is equal to 0. So now fix z is equal to k, then from this equation we got y is equal to k by 2. Thereafter by using this equation we got x is equal to minus k. So hence for this x, y, z is equal to minus k, k by 2 k, that can be written as k by 2 into minus 2, 1, 2, which gives, that is vector minus 2, 1, 2 is an eigenvector corresponding to lambda is equal to 2. Similarly, let us find eigenvector corresponding to the eigenvalue lambda is equal to 3. We got the equation A minus 3i of x is equal to 0. On performing this, we got the equation as minus 2, 0, minus 1, 1, minus 1, 1, 2, 2, 0, x, y, z is equal to 0, 0, 0. So reduce this into echelon form by using the row operations, R2 as 2R2 plus R1, R3 as R3 plus R1, we get this minus 2, 0, minus 1, 0, minus 2, 1, 0, 2, minus 1, x, y, z is equal to 0, 0, 0. Finally, Fix this, make down 0 using the operation R3 as R3 plus R2. So clearly here again rank is 2, which is less than number of unknowns. Write on the reduced system, minus 2x plus 0y minus z is equal to 0. And from the second row, 0x plus minus 2y plus z is equal to 0. Now fix one of the variable as arbitrary constant. Let us take y is equal to k. Then by using this equation, we got z is equal to 2k, and by means of first equation, we got x is equal to minus k. Therefore, the eigenvector corresponding to lambda is equal to 3 given by xyz minus k, k, 2k, that is equal to k into minus 1, 1, 2. So, gives the eigenvector minus 1, 1, 2 for the corresponding eigenvalue lambda is equal to 3. So, hence we got all the 3 eigenvalues x1, x2, x3. Since all the eigenvalues are distinct, hence x1, x2, x3 are linearly independent. So, hence we say that A is diagonalizable. And now consider the model matrix P, that is equal to x1, x2, x3 as column. So, therefore, what will be P is equal to x1, which is minus 1, 1, 0, x2, minus 2, 1, 2, x3, that is a minus 1, 1, 2. We need P inverse also. So, the inverse of the matrix P is given by P inverse, and that is equal to 0, 1, minus 0.5, minus 1, minus 1, 0, 1, 1, 0. So, now do P inverse AP. Substitute what is P inverse, given matrix A and P. On doing this multiplication, we got a diagonal matrix in which diagonal elements are eigenvalues. So, therefore, by means of a similarity transformation, you are able to diagonalize the given matrix into diagonal matrix. So, now we will have one another question, that is, we need to find out A power 5. So, in order to find out A power 5, we can use this. We know that A power n is equal to P into D power n into P inverse. Hence, therefore, what is A power 5 must be equal to P into D power 5 into P inverse. That is equal to, substitute P matrix 1 minus 2 minus 1, 1, 1, 1, 0, 0, 2 into D power 5. D power 5 is the diagonal matrix, D is the diagonal matrix which we need to make power 5. So, hence it is enough to make diagonal elements as to the power 5, means 1 power 5 0 0, 0 2 power 5 0, 0 0 3 power 5 into P inverse. Already we calculated P inverse, which given by 0 minus 1 0.5, 1 1 0, minus 1 minus 1 minus 0.5. On doing the multiplication, we got A power 5 is equal to minus 1 by minus 179, minus 180, minus 121, first row. Second row is 211, 212, 121, and the third row is 422, 422, 243. So, at the end of this lecture, what we learnt is how to diagonalize the given matrix using similarity transformation. Means first we got how, in what condition the matrix, given matrix is a diagonalizable, so that we are able to make a diagonalizable using similarity transformation. Not only that, we got an application also, that is how to find higher powers of the given matrix. Thank you.